Hi all, welcome to my YouTube channel Know About Embedded System. In today's video, we're going to discuss one of the important topic in our embedded system that is called as a timer. So you might be knowing already, so what is a timer? In your wristwatches, in your mobiles and in your digital clocks, whatever you're going to see the clock, no, that is actually the developed by timers only. So today we'll be discussing about the timer, how timers are used in our embedded system. That part we will understand. So before starting the video, if you're a new viewer to my channel, kindly subscribe my YouTube channel and gain the knowledge on embedded system. So let us start the video here, timers in embedded system. So guys, in the real-time embedded system, it is not at all possible to design any embedded system without timer. So timer plays very important role in our embedded system application in order to schedule the different activities in the embedded system. Best example I'll give you, washing machine. If you take the washing machine, we have timer. If you take example of your microwave or oven, we have we have timer inside. Like that, embedded system cannot be designed without timers. So timers plays very important role in the switching different applications time to time. So that is why for any embedded engineer, it is necessary to know the timers. Okay, so let us start in detail video. What is timer and how it is used in the embedded system. So basically, guys, what the timer will do. Timer is one of the simplest circuit in the embedded system. This is going to count the clock pulses of your the crystal oscillator what you are going to provide. Here you can see this is complete my microcontroller. Inside the microcontroller, there is a CPU and there is a timer here. So what timer will do? Timer will simply it will count the clock pulse, and based on the clock pulses, it is going to based on the delay requirement, the clock pulses will be counted, and according to that, the output will be given. So what is a timer stands for definition? You can see timer is a microcontroller. Timer in the microcontroller is a hardware peripheral. It's of course it is a hardware circuit. Physically, this will be present in the microcontroller. And what it will do, it will count the clock pulses which are given from the crystal oscillator, and it will enable the measure time. So this is responsible for measuring the time, and this is responsible for measuring the precise delay, and also it will trigger the different events on the regular interval. This is what I told. With the help of timers, the best example is washing machine. With the help of timers, we can trigger different action, different applications. Okay. So what it will do, it is an independent circuit. This will not involve in the CPU operation. So dedicated registers available, dedicated circuitry is available, dedicated functionalities are available, and with the help of those functionality registers, we have to configure and we have to get the output. Okay, so this is your basic definition of your timer. What are the applications or what are the functions of the timers? So why we have to use the timers? So if you want to count some external events, we will use a counter. So timer can be used as a timer as well as counter. Both way you can use. So inside the timer there will be a counter. Using that counter we can count the external events. So that's one of the things. And if you want to generate accurate delay, I want to generate 100% accurate delay, then we will use timer. And then if you want to schedule the different applications, best example again I'll take a washing machine here. Different functionalities are defined in the washing machine. Based on the time, different functionalities will be triggered with the help of timer. With the help of timer we can generate pulse width modulation. With the help of this pulse width modulation is used to control the speed of the motor. If you want to capture the time of any particular event, let us assume there is one event, and that I want to know at what time the event has been occurred. So this is called as capturing. There is an event and that event has been occurred in the embedded system, and I want to measure the time of that particular event. So in that situation it's called as a capture time. So we can capture the time of the event. We will use timer to capture the event, and we will use timers to generate interrupts. We will use timers to manage an external event. I want to control some motor speed based on the time. Again, best example again I'll take washing machine. Different speeds, different functionalities we can manage with the help of timers. And finally, the synchronizing different components. If you have 10 different applications, those 10 different applications will be synchronized with the help of timer based on the time unit. So that is why timer plays a very important role in our embedded system. Without timer, it's not possible to design any embedded system. I hope this is clear. So how this timer works? So let us understand how this timer works. So timer circuit is very simple. Already we have seen in the introduction slide. So timer circuit is very simple. This is a simplified block diagram. So here the clock, whatever you're seeing, this is your peripheral clock, or you can say crystal oscillator clock. And this is your main timer counter. And this main timer counter is responsible for counting the clock pulses which you are supplying. So this clock supply will be either given from the peripheral clock or from the crystal oscillator. So, and we have one more block here, Prescaler. So with the help of Prescaler, we can step down the clock value. If you want to step down the clock value, we can use a Prescaler here. If you don't want, you can just neglect this part. So this is a configurable. If you don't want anything, keep this Prescaler as 1 so that it will be divided by 1 only. Okay, so Prescaler plays an important role again if you want to step down the clock. The clock, whatever you're supplying, will be given to the timer counter unit here. What the timer counter unit will do, very simple, this timer counter unit or a timer counter will just count the clock pulses which you have given from the peripheral clock or a crystal oscillator clock. So this it will just keep on counting. It's an up counter. Okay, and on the upper side you can see if you want to generate any functionality. I want to generate one function after 10 seconds. Let us assume I'll take one example here. I want to generate one function or one application I want to run after 10 seconds. So that means whenever timer counter reaches 10-second value, this will generate one interrupt like this. One signal it will generate, and that is called as timer output module. So the one pulse will be given to the timer output module, and this timer output module in turn it is going to generate different functionalities. So with the help of timer output module, we can generate interrupt, we can generate pulse width modulation, we can generate watchdog timer output, and also we can control the different output devices based on this timer output block. So under this, many functionalities will be defined. Okay, now here timer will count, and whenever there is a match condition, I told you 10 seconds, I have taken example, right? So whenever your counter reaches with a 10 second, so it will generate one clock pulse like this. Timer will generate one clock pulse, and based on that, any one of the functionality will be triggered. So this is a simple working. This is also called as compare mode. Timer can be configured in a different operating modes that I will be discussing in the next slide. Okay, the next one here in the bottom you can see capture input. So one mode is called as this block, whatever you're seeing, this is called compare mode. In the compare mode, timer will be compared with a predefined value. On the other hand, the bottom part, what you're seeing, so initially the timer will be running in a free running mode. Free running mode means it continuously runs without any obstacle. In between, if there is an event, let us assume there is an event here. If there is an event like this, I want to measure at what time the event has been occurred. There is an event or there is an interrupt here, and I want to measure at what time the interrupt has been occurred or at what time the event has been occurred. That is called as capture mode. So timer can be configured in a two major operating modes. One is compare mode and one is called capture mode. Compare mode, the timer will be compared with a predefined value, and in capture mode, events will be captured. Events will be captured, and that particular time will be given to the timer output module. And from this timer output module, if you want, you can store it in the memory or further, however you want, you can utilize that. Okay, so this is a simplified explanation of the timer. The same thing I have kept it here in the bulletins. Clock source, either it will be given from the external source or from the peripheral clock and so on. Prescaler, the prescaler, as I told you, this is used to step down the clock what you're supplied here. If you don't want to step down, keep this value as a 1 so that it will be retaining the same value, and the same clock will be supplied to timer counter. Timer counter, this is a main circuit. This is going to count your clock pulses. Counting modes, this timer can be configured as up mode or down mode. Any way you can do, but by default, most of the time, timer will be configured as upper mode only, up count only. Okay, this is also possible to count in a countdown down counter as well. For that, we have to configure the different register. Modulus value, nothing but match value, this point. So match value is nothing but predefined based on the time unit. Timer overflow. So whenever there are two scenarios here, whenever match condition occurs, this will overflow, timer will overflow, and then based on that, timer output will be configured different functionality. And second thing is, whenever timer reaches maximum value, it will roll back to 0. That is called as timer overflow. And then interrupts. So interrupts, as I told, whenever there is a match condition or whenever there is a rollback, rollover, then it is going to generate interrupt. So this is how the timer is going to work internally in a generic way. I hope this is clear. Then, so here I have taken with a clock diagram. So the same diagram I have considered. This is your peripheral clock. This is the simple clock. It will just keep on giving, will be given from the peripheral domain, peripheral clock source. And here you can see this is my timer counter. So whenever peripheral clock is given with a 0, your timer counter will start counting here 0, 1, 2, 3. And you just see here the match value I have given as this match value, or compare input I have given as 5 here. So whenever your timer reaches to 5, you can see here 0, 1, 2, 3. This is your timer counter, this block. Timer counter will start counting 1, 2, 3, 4, 5. And whenever it reaches with a 5, the interrupts will be generated. So whenever both are equal, interrupt will be generated. And then uh, timer output module will come into picture based on the interrupt, what functionality you want to design, whether you want to generate pulse width modulation, watchdog timer, and so on. Okay. And then if you want, you can configure timer in a free running counter as well, or else you can roll back to 0. So in this scenario, I just made it as rolling back to 0 and again start with a new cycle. So both possibilities are there in the timer. Both way you can do the configuration in the timer. Okay. Timer modes. Okay. The first one is simple timer mode. What do you mean by simple timer mode? So this timer is there, no? This will be counting simply as up counter. It just go on counting 1, 2, 3 up to maximum value, and then it will come back to 0. That is called a simple timer mode. Second one, interrupt based mode. Interrupt based mode. So you know that already. Interrupt can be generated in a two different way in the timer, one with a match value and one with a capture input. Both way you can generate. So that is called as interrupt based model. PWM. So timer also can be configured as a PWM mode. PWM stands for pulse width modulation, and this is used to control the speed of the motor or light intensity or your headlamps. In your cars, we will have a different headlamps now that can be controlled with the help of PWM. Timers also can be configured as a watchdog timer. This I'll be explaining in an upcoming video later. Just keep it in mind. Timer also can be configured as watchdog timer. Timer events. So that means here, like I'll give one example here. Let us take two different use cases here. Like 4 different examples I'm taking here. I have 4 different events, and each event should be triggered for every 10 seconds. So event number 1 after 10 seconds, event number 2 20 seconds, event number 3 30 seconds, event number 4 40 seconds. So based on the time unit, I want to trigger different events with the help of timer output module. Okay, timer will count, and every 10 seconds it will generate interrupt, and timer output model will trigger different events. That's called as timer events. Best example is again washing machine. Output compare mode. Output compare mode in the sense it's a nothing but simple compare mode. We're going to compare your match register value with a timer value. Input capture. This already I have explained you. For every, if there is any event that will be captured, and that event time I want to capture. So event has occurred and I want to capture that time. So that is called as input capture mode. Auto reload mode. Auto reload mode means with the, for example, timer will run and I will start from this value. Okay, this is my predefined. This is let us assume this is my auto reload mode. But by default, what will happen? Timer will always start from 0000. Whenever timer resets, no, the timer will always start from 000. But sometimes, based on the application need, we can reload to different value that is called as auto reload mode. So whenever timer completes its upper limit, and it should go back to, it's supposed to go back to 0, but in auto reload mode we can define auto reload mode. In this auto reload mode, it is going to take you to the predefined value. It will auto reload to different predefined value. That is called as auto reload. And almost all embedded systems we're going to use traffic lights, right? So traffic lights, fitness equipments like your wristwatches and your treadmills and so on, and alarm systems. Okay, so these are all the applications where you can see the timers. This is what I told in the introduction part. Without timers, it is not possible to design any embedded system application, and the timer plays very important role. Okay, so with this, I want to end my video here. So if you feel this is an informative video, please click on the like button and subscribe to my YouTube channel, Know About Embedded System. Let us meet in the next video again.